Hello champion, I'm teacher Adam. Welcome to my math class. Today we are still continuing with the topic of numbers, and we are going to the subunit of surds. What are surds? That's what I'm going to start with. As we said before, surds are the square root of numbers that are not square. We know when finding the square root of numbers, it's easier. It's very, very simple. Like square root of 9 is 3, square root of 25 is 5. It's easier. And we know you can only get a square number by multiplying a number by itself once, like 5 by 5, and you get 25. So to find its square root, you get 5. So that's what we were learning. But in this case, when we're going to learn about surds, we need to understand the idea that when you're finding the square root of surds, it means you're finding the square root of numbers that are not square. For example, square root of 3, you'll obviously get a number that continues, like you have a number with a recurring decimal, like square root of 3, square root of 2, square root of 5, square root of 7. You see those kind of numbers, you will not be able to get a whole number, and that's it. So we say, in other words, we say that this surds are the square root of numbers that cannot be simplified into a whole or rational numbers. We said what are rational numbers from our previous class? We said this. We said rational numbers are all numbers that can be written in the form of a over b, or that can be written in form of fraction, like 1 over 5, 1 over 7, 2 over 3, all numbers. But those numbers that cannot be written as a fraction, they are called irrational. For example, square root of 3, square root of 9, that means any number that has 1.7, 1.9327, whatever, that continues. Those numbers that cannot be written as a fraction, they are all called surds. Now, in surds, what's the most important? Now, in IGCSE, both extended and core, they normally test. For example, in core, they normally test. In extended, they normally test how to rationalize. The meaning of rationalizing is what I'm going to introduce today. Rationalizing. To rationalize surds, in other words, we say it means also simplifying. Simplifying surds. So that's the most important, like simplifying surds. So in simplifying, because when you say we are rationalizing, in other words, it's like to simplify. So how do we rationalize surds? That's the most important thing that we need to understand. We need to know that to rationalize a surd is the process of converting the denominator of a fraction from a rational number, like square root, to a rational number without changing the value of the fraction. So this is achieved by multiplying both the numerator and denominator of the fraction. So we understand about that. So normally, when you're talking about rationalizing, it means, in other words, for example, if you're given a surd in form of a fraction, and then when you're talking about rationalize or simplifying surds, it means normally it's always, to rationalize surds, you have to multiply a surd by its conjugate. And what is a conjugate? We say a conjugate is formed by changing the sign between two terms. So you can change the sign of algebraic expression that is written in form of surd, and then change their sign. For example, if you have an algebraic expression, for example, be x plus 5, its conjugate will obviously be x minus 5. If you have x minus 7, its conjugate will be x plus 7. So that when you simplify by expanding, is the same as finding the difference of two squares. And that's it. So in rationalizing surd, in other words, in rationalizing surd, we say the conjugates are frequently used to eliminate radical. It means you remove the square root sign. In other words, you're going to simplify the square root sign. And obviously, when you have, for example, 3 plus root 5, it's 3 plus root 5 is an expression that is written in form of a surd with a whole number. So to find its conjugate, it will be the same number with the same radical but different sign. So for example, it's 3 plus root 5, its conjugate will be 3 minus root 5. If you have a surd written like, let's say, 2 plus root 7, its conjugate will be 2 minus root 7. So if you have a surd written maybe 3 plus root 5, so its conjugate will be 3 minus root 5. If you have a surd written maybe 6 plus root 3, its conjugate will be 6 minus root 3. And when you multiply these two, is the same as expanding or finding the difference of two squares. That's nice. So we are going to see how we are going to simplify surds, and in most cases in IGCSE Math Extended, they can give you rules and say, right after simplifying, leave your answer in the form of a plus root b. You understand? So it means they want you to leave your answer in the form of surd or a plus. So using of calculator in those kind of scenarios will not be prohibited. So you have to be careful and understand this unit so that it's easier for you to solve a non-calculator math extended paper. Join. Let's go. So we have, maybe we have a question and then say, how do we rationalize? For example, we say to rationalize the denominator of the fraction. Let's say we have a over root 3 plus 2. Maybe we have a question like that. And we say to get a complex, to get a conjugate for root 3 plus 2 is the same as root 3 minus 2. Therefore, in surds, to rationalize means you have to get a conjugate. So this is the respective conjugate. Multiply with the respective conjugate in the denominator and numerator. Remember, when you are rationalizing a surd, is obviously you are simplifying. Your idea is to get rid of the square root sign, from the denominator. So in that case, you have a out of root 3 plus 2. So its conjugate will be root 3 multiplied by root 3 minus 2, both in numerator, and denominator with the same. And when you expand this, root 3 times root 3, obviously it will be 3. Multiply that with that, it will be minus 2 root 3. Then take this, 2 times root 3, it will be plus 2 root 3. Then 2 times negative 2, it's minus 4. Then negative 2 root 3 plus 2 root 3. We did on the previous, we said when adding the surds, you can add the coefficient. So if you add here negative 2 root 3 plus 2 root 3, they simplify and get 0. These two turns to 0, and you have your answers 3 minus 4, negative 1. After getting negative 1 on the numerator, then you will divide. After dividing, you get negative 1 into a root 3 over 2a, and then open with negative 1, you get negative a root 3 plus 2a, then start with a positive value, a positive number, which will be 2a minus a root 3. And that's how you end up getting your answer in surd form. Okay, we have 3 over root 5 plus 3. And then they say, rationalize this. This is another example. Rationalize this. What is our conjugate? Our conjugate will be the same radical, but different sign. And then you multiply. You multiply on the denominator, multiply on the numerator, the same. Sorry, this will be root 5. Then you multiply. Root 5 times root 5, what do you get? You get 5. Root 5 times that is minus 3 root 5. Then 3 times root 5 is plus 3 root 5. And then 3 times negative 3 will be minus 9. And then when you add this here, is the same as 0. So 5 minus 9 is minus 4. Correct. Now you come here and then you say, if you multiply on top, you get 3 root 5 minus 9 over minus 4. This is the answer. This is the answer. So the answer can be, you can either decide, say, negative, or you just say 3 root 5 minus 9 over negative 4 to be your actual answer. This is what you need to do when you're taught to rationalize. Rationalizing. Then we have, you can have, maybe say, you have 2 over, they say, root 3 plus 5. What else? How do you rationalize? You say to rationalize is getting rid, you are getting rid of the surd in the denominator. So in other words, you have to multiply by its conjugate. And we know a conjugate is the same surd, but different sign. So you have root 3 minus 5. Okay, multiply by root 3 minus 5. You multiply the same in the denominator, the same in the numerator. Then expand. Root 3 times root 3, you get 3. Root 3 times negative 5, you get negative 5 root 3. This we did in law of, we did this in multiplying. We did this in multiplying surds with coefficients. And then you go back again. Plus 5 times root 3 is plus 5 root 3. And then plus 5 times negative 5 is minus 25. So you see this will turn to 0. Negative 5 root 3 plus 5 root 3 is 0. And then 3 minus 25, what is it? 3 minus 25 is minus 22. Okay, then on top, 2 times root 3 is 2 root 3. 2 times negative 5 is negative 10 over negative 22. And we can simplify in that case. We can say we open with negative 1. Negative 1, we can say we open with negative 2. Negative 2 into root 3 minus 5, obviously. And then at the bottom, we can say open with negative 2, and you'll have 11. Simplify. Negative 2 by negative 2, cancel. And then on top, you have root 3 minus 5 over 11. This is our answer. Wow, as simple as it is. Dear candidate, you see how it's simple when you have to rationalize and solve these kind of questions, especially the ones that come in your IGCSE math. They'll give you those kind of questions. Let's see a different scenario here. They say 7 out of root 8 plus 2. Yeah, root 8 plus 2. So get the conjugate. It's root 8 minus 2 times on top root 8 minus 2. When you expand this, root 8 times root 8 is 8. That's 8. And then root 8 times negative 2 is minus 2 plus minus 2 root 8. And then 2 times that is plus 2 root 8. And then that times that is minus 4. So this, in this case, you have negative 2 root 8 plus 2 root 8. This one will be 0. So 8 minus 4 is 4. Now you go to the top. To the top you say 7 times root 8 is 7 root 8. 7 times negative 2 is minus 14 over 4. That's it. And you end up getting your good answer. That's what you do. You will have simplified, or you will have rationalized the surds. You see how it is easier to rationalize the surd. Okay, we have this kind of question. Sometimes you might be given a different question and they want you to specifically show them like what to do. For example, you are given a question and then maybe leave your answer in this kind of form. Let's say, for example, this one. You have, yes, we have now on top, we have 4 plus root 8. And then at the bottom, we have root 2 minus 1. And then they say, rationalize this. What do we basically need to do? In this case, you have to multiply with their respective conjugate. So it's root 2 plus 1. So this is root 2 minus 1. Multiply by root 2 plus 1 times root 2 plus 1. Wow, that's fine. Then expand. Root 2 times root 2, what do you get? It is 2. And then root 2 times that one is plus root 2. Then negative 1 times that is minus root 2. This one times that. And then negative 1 times 1 is negative 1. So this one here, you end up getting 0. So 2 minus 1 is 1. Then on top, when you multiply this 4 times root 2, it is 4 root 2. Then plus, so 4 times that is 4 times that is 4 root 2, and then 4 times that 4 times 1 is 4 times 1 is 4, and then root 8 times root. So in this case now is a bit, you need to be very smart. Root 8 times root 2. Now when you what did we say when you're multiplying numbers? For example, root a times root b is the same as root ab. So if you have root 8, remember root 8 is the same as root 4 times root 2, because it can be 4 times 2, and then you can simplify them. You say root 4 times root 2, and then this is 2 root 2 times root 2, and then 2 root 2 times root 2, 2 root 2 times root 2, you get 2. So 2 times 2, you get 4. That can be an easier way. Or an easier option, if you don't know, if this is a bit complex with your understanding, you can as well say it can also be the same as, remember this law, this one, root a times root b is the same as root ab. So you can say 8 times 2, which is the square root of 16, and get 4. You see, you need to understand this. Root 4 root 2 plus 4 plus 4, and then root 8 times root 2, we know it's plus root 16, which is 4, and then root 8 plus times 1, root 8 times 1 is plus root 8. And then let's add 4 plus 4 coefficient, it's 8. So we say it's 4 root 2 plus 8 plus root 8. And then remember here, 4 root 2 plus root 8 plus 8. Still, this one can be simplified. It can be simplified. What can be simplified here? You say 4 root 2 plus, remember, this is the same as 4 times root 2. And then here it can be 4 root 2 plus 2 root 2. And then if you do this, in this case, their coefficient, you can say 4 plus 2 is 6 root 2 plus 8. This is how you get your answer. 6 plus, because 4 plus 2, their coefficient, you add this 4 and 2, add up. 4 plus 2, you get, in that case, you say 4 plus 2. So if you don't know how I got this answer, it's 4 plus 2 and then root 2. Because if the surds are the same, you only add the coefficient. That's laws of surds that involve addition, addition property in surds. So you say 4 plus 2, you get 6, and then you keep the surd the same. So you get 6 root 2 plus 8. It's now plus 8. You say 6 root 2 plus 8. Therefore, but remember, there when you simplify, it was out of 1. So 6 root 2 plus 8 over 1 is the same as 6 root 2 plus 8, which is your answer. You keep it the same. You see, now this is how you solve champion questions that involve surds, how you're supposed to rationalize, and you get your answer correctly without struggling. This majority of the questions, like this one, they are always 2 marks question. They are always 2 marks or 3 marks questions at most when you're supposed to solve. So I'll solve the rest of the questions in the same scenario. But what do we understand? Remember, from the previous class, we talked about addition property of surds. For example, we said on addition property, so at least we review this so that you have an early understanding of what we did on the previous class. So this is just review so that you can be able to rationalize more. We talked about addition property of surds. We said in addition property of surds, rule number 1, it was when you have a root b plus c root b. What did we say? You say you add a and c, like a and c add, and then you keep the b the same. Remember, you add only the coefficient a and c and keep the surd the same. So for instance here, you have 3 root 7 plus 2 root 7. what do? You add the coefficient 3 and 2. They are coefficients. They are coefficients of the surd root 7. Now, since the surd is the same, you only say 3 plus 2 and then keep, which will give you 5 root 7. You get it? Or you can say you have 8 root 5 plus 2 root 5. 8 and 2, they are coefficient of the surd, root 5. Therefore, you add 8 plus 2, and then you keep the square root, root 5, the same. When you add this 8 plus 2, you get 10 root 5. This becomes your answer. The answer, the same. Wow, perfect. We went to subtraction. We reviewed also subtraction property that involve surd, the subtraction property in surds. What did we say? We said the same thing. If you have a root b plus c root b. Oh no, this is a subtraction. Yes, a root b minus c root b. What did we say? We said the same thing. You keep you subtract the coefficient a minus c and keep the same. You keep the surd the same. For example, let's say 5 root 2 minus 2 root 2. What do? In that case, you say 5 minus 2 and then keep root 2. Then your answer will be 3 root 2. Let's say 9 root 3 minus 2 root 3. What do you do in that case? You say 9 minus 2 and then keep root 3. So your answer will be 7 root 3. What if I have 10 root 5 minus 3 root 5? What do I do in that case? I'll say 10 minus 3 and then keep root 5 the same. So what do I get in that case? 10 minus root 3 is 7 root 5. We did this. Okay? That's subtraction. Subtraction. And then we also talked about multiplication property. Multiplication property in surds. What did we say about it? We said when you have, let's say, a root b multiplied by c root b. What did we say? You can multiply you will multiply first of all. Let's say rule number 1 before going to this. We said rule number 1, let's say you have root a times root a. Root a times root a is the same as a. What is being cancelled? What cancels is the square root. For example, if you say root 2 times root 2, your answer will be, basically be 2. If you say root 3 times root 3, your answer will be 3. Even if you use your calculator, just do root 3 times root 3. You'll obviously get 3. If you say root 5 times root 5, you will obviously get 5. This is the first skill or the first law that you need to understand and have it on your fingertip. And then we go to rule number 2. They say if you have now, you understand that, and you have now c root a times b root a. What do you get in that case? We say you multiply c times b and times a. How? Let's say in that case, this will be the same as ABC, your answer. Let's say you have 2 root 3 times 3 root 3. In that case, your answer will be 6. 2 times 3, you will multiply. Your answer will be 2 times 3. Your answer will be 2 times 3 and root 3 times root 3. So 2 times 3 is 6. So it will be 6 times 3, which is 18. As simple as it is, dear champion. You see, now these are the majority of the commonly asked question. And then we can talk about now. You can talk about maybe if you are for example, maybe you have now, let's say you have scenario. In this case, you have root 3 times root 5. We say this property here is the same as when you have maybe root a times root b. This, you say, is the same as square root of ab. This is also a rule, another rule. So you can as well say 3 times 5 and say is the same as square root of 15. So square root of 15 is equal to the square root of root 3 times root 5. This is another rule. I hope we understand. So in that case, if you have two numbers, let's say 3 root 5 times 7 root 3. This one can be the same as 3 times 7 and then root 5 times 3. So this can be the same as 21 root 15. This is also a rule that involves multiplication property. And even the division property is not. So division property. Remember, division is the opposite of multiplication. So for example, let's say we have 9 root 3 divided by 3 root 3. What do we do in that case? What do you do in that case? Remember, coefficient is 9 root 3. It can be also written as 3 root 3. So remember, we say root 3 divided by root 3 is 1. Obviously, we know that. And 9 divided by 3 is 3. So you divide each coefficient separately. You divide coefficient by coefficient and surds by surds. Root 3 divided by root 3 is 1. So multiply by 1. So in that case here, you will say 9 divided by 3 dot root 3 divided by... That's what you do, champion. And that marks the end of our lesson today. See you at the top, champion. Bye-bye.